Hello everyone, welcome to CSE490 Introduction to Quantum Computing. You know, this is a special topics course. In this course, we are going to learn how to use the weird effects of quantum physics and quantum mechanics to perform computational tasks. In recent years, quantum computing has seen a huge surge in industry and academia, and research centers and research laboratories all over the world are investing heavily in doing research in quantum computing and quantum information theory. Even big industry players like Google, IBM, and Microsoft are also investing heavily in this field. You will see that using the principles of quantum mechanics and quantum computing, we can actually perform tasks that it would take thousands of years for classical computers to perform. And if we are able to achieve these tasks in real life, experimentally and through computational systems, then it is probably going to be the biggest technological breakthrough of the 21st century. Okay. Another exciting aspect for you in this course is that this is the only academic, this is not the only, actually the first and the only academic course in quantum computing in Bangladesh. Okay, so it was an initiative by the head of our department that we should pursue studying this field, studying these concepts, so that our graduates can become aware of the global trend and research surge in quantum mechanics and quantum computing. So you are probably lucky that you are getting to learn these concepts such early on, and you can use this knowledge to advance uh, your future endeavors if you want to pursue this field. Alright, so let's see who will be with you throughout this course. This is our course team. Our course coordinator and our main lecturer will be Wasif Ahmed, and supplementary lectures and problem sets and tutorials and discussion sessions will be provided by me, Shomitra Dash, and Arpan Paul. Alright, so this is the team. What topics we will be covering in this course? A short review of the syllabus will be, we at for the first couple of weeks we will spend some time learning about quantum mechanics. All right, well, definitely if we want to perform quantum computing, we need to know how quantum mechanics works so that we can use them in computational tasks. To learn quantum mechanics, we will need some prior mathematical knowledge. Particularly, we will need to know or review some concepts of linear algebra and probability theory. Alright. In most cases, we will discuss the mathematical concepts that are relevant for the topics beforehand, before jumping into using them for learning quantum mechanics. And then we will spend some time learning about the postulates of quantum mechanics and how to work with systems and mathematically describe systems that work quantum mechanically. Alright, then after learning quantum mechanics, we will move on to different aspects of quantum information processing. Okay, we will learn some topics on quantum communication and quantum cryptography. Quantum communication and cryptography. We will learn about quantum circuits, and finally we will end our course with learning about quantum algorithms. Okay, a big attraction of this course is that we will try to show you um, how to run programs on a real life quantum computer. All right, as you know, as I said earlier, that several uh, big industries are investing heavily in quantum computers, and many of the companies like Google and Microsoft and IBM have small quantum systems up and running. So in this course, we will show you how to actually run programs uh, on an quantum computing system designed by IBM. All right. This we will go to this part in the later part of the course after you have learned about some basic quantum computing and quantum mechanics. IBM has actually built a system called IBM Q, and it is open to researchers around the world. And it has a software library called Qiskit that we can use to program the circuits on IBM Q. Alright, so hopefully that will also be an exciting experience for all of us. Alright, let's talk about some resources that might become helpful to you throughout the course. Um, as we told you that we'll be needing some prior mathematical knowledge to learn the concepts of quantum mechanics. So particularly we will need linear algebra and probability theory. So hopefully you have already done courses on these topics, and it might be useful to review these topics. We will actually provide a short review at the beginning of this course. If you want to review from some books in a condensed manner, then one of the books I could suggest is Mathematical Methods for Physics and Engineers. Mathematical Methods for Physicists and Engineers. Physics and Engineering by Riley and Hobson. This can provide you a quick and short review of the topics related to algebra and probability theory. It is written by Riley and Hobson. Alright. For the main part of this course, we will be following some lecture notes from Cambridge University by Richard Joza. Okay, he is one of the pioneers of quantum computing and invented a very fundamental quantum algorithm. We will actually learn about his algorithm as well. So we will use some Cambridge lecture notes. We will actually provide you the lecture notes as we keep using them uh, throughout the course, so don't need to worry about those. And in addition to these notes, you may want to do some personal study if you are interested enough. Alright, then you can read the following books. There is a book called Quantum Systems and Processes. Quantum Systems, Processes and Information. It is written by Schumacher and Westmoreland. The Schumacher guy is also a very famous person in quantum information theory, and he proved a pivotal theorem on quantum channels. Alright, so this is a good book, and well, if you are really interested in this topic, then you could see another book called Quantum Computation and Quantum Information. Quantum Information. This is written by Nielsen and Chuang. Alright, so this book is actually considered as the Bible of quantum computing and quantum information theory. Every major research area that is being worked on in quantum computing and quantum information right now is discussed in this book. If you are well savvy in mathematics and would like to check out the emerging topics in this field, then you could read that book. It is a very comprehensive book. Alright. Okay, so those are the main resources that you might need throughout the course. Hopefully the course will in itself be self-contained, so hopefully the lectures and discussion sessions will be enough to make you understand the topics, but it is a quite mathematical course, and you have to think on your feet and work hard to understand the concepts, because well, quantum mechanics is not intuitive. Well, people learning it the first time do struggle to learn these concepts, so you need to put in some time and effort to understand all the concepts that we'll be introducing in this course. All right, and lastly, I would like to talk a little about the course management. Okay, so in the course, yeah, for every week you will have a sequence of video lectures. Okay, we have tried to break down the lectures as much as possible, so that each video is very short and introduces only one concept, so that you can focus on that concept, and so that it doesn't overload your attention span, or well, or the amount of megabytes that you may have in your computer or mobile. All right, so followed by each video lecture there will be a short quiz. This will be basically a mathematical problem or like an MCQ at the end of each lecture, so that we can check how much you have understood the lecture. All of these will not be so straightforward, so you may have to think a bit on how to answer these questions based on the concepts introduced in the videos. All right. Then at the end of a week or at the end of 2 weeks, we will have an assignment or a problem set. Okay, this problem set will cover all the lectures given in that particular week. Okay, so you might need to think more broadly in terms of all the concepts that have been introduced in the week to answer the problems of this problem set. Mind you that these will be graded. Okay, these will be graded, so try to work hard and learn the concepts properly to learn them. All right, then probably from week 3 or week 4 we will try to hold some tutorial classes. In those tutorial classes we will discuss about discussed in more details about some concepts of quantum mechanics and quantum computing and quantum communication that we might not be able to cover in the class. Okay, hopefully this will help you to deepen your understanding of quantum phenomenon and quantum information theory and quantum computing in general. All right, then we have consultation or discussion classes. We'll have them almost every week, so that um, you can talk to us about if you have any problems that you might be having, or any of the concepts that you might not be understanding. This session will be to answer all your questions, and this will be analogous to the consultation sessions that we have at our university, but just they will be online. All right. Besides to the discussion classes, there will be discussion forums at the end of each lecture. So if you have an immediate question that you have after watching a lecture, then you may discuss in those forums, or perhaps the course teachers or some other of your friends who have understood those concepts can help you in answering those questions. All right. Then finally we have our midterm exams and our final exams. Midterms and finals. All right. So we haven't actually figured out yet how this is going to be taken place. Perhaps the university will figure things out as they go on. Okay, so don't need to worry about those for the time being. Just focus on the lectures and try to do the problems so that you gain a good understanding of these topics. All right, hopefully you will have a probably fun and exciting and a bit head scratching time to understand this course, and hopefully at the end of this course you will have all the tools in your hand to perhaps go further if you want in this field, to study quantum computing, or perhaps do an interesting research project if you want, or if you want to contribute to the field of quantum computing in general. Hopefully we will have a good time. Thank you.